Okay, so now that we've seen the law of sines and the law of cosines, the reason why I hate the law of sines, that's coming, but not yet. We're going to end up with a little bit of formulas for the area of triangles. We have 3 different versions that we can use and apply. The first version is what you guys remember, hopefully, from your geometry days. It's 1/2 base times height. The height being the altitude. There has to be a perpendicular height. This h has to be perpendicular to a side. Then it is. It's just base times height divided by 2. Standard form area of any triangle. The next one, if you have a side angle side dependent, or if you have a side angle side triangle, you can find the area by doing this formula, 1/2 times the 2 sides that you have. If it's side angle side, you have 2 sides, times the sine of the angle that you're also given. That back piece, C sine A, if you just look at that piece, that is a way to find a perpendicular height, an altitude. If we drew our little right triangle, that would be h, if you remember that from our derivation. So these say the same thing, but this one's neat and tidy. If you ever have a side angle side triangle, you can just use this formula to find the area of said triangle. The last one then is a little bit of a beast. If you have all 3 sides of a triangle, you could find an angle using the law of cosine, and then now you have a side angle side, and you could do this. But there's also something called Heron's formula. Heron's formula is pretty wild. I tried to look into the derivation once to show one of my classes, and it was beyond the scope of the class for sure. I looked at it and I kind of got it, but kind of not. So here's the actual formula. We can still use it. The area is the square root of s times s minus a, s minus b, times s minus c, where s is this new number we get by adding all 3 of our sides and dividing by 2, which started to wig me out. The whole time I looked at it, I'm like, wait, adding all of them and dividing by 3 would be their average, but why are we dividing by 2? So I went and looked into it, and it was a doozy. It was out there, but still a good little formula for us to use if you ever want to find the area when you know all 3 sides of a triangle. This is a way to go about it. So let's do one little practice. Use the appropriate formula and find the area for this thing. Okay. Hit pause if you need to. Looks like it's side, side, side to me, so I'm going to use Heron's formula. I haven't done it yet, so let's do it and see if I still have the skills, okay? The first thing we have to do is find that s. To find the s, we're going to add 17, 12, and 15, and divide by 2. Okay, so I'm going to get my calculator. I'm going to add 17 plus 12 plus 15 divided by 2, and s is 22. So now that I know what s is, it's a, the area, is the square root of s, times s minus one of the sides, times s minus one of the other sides, times s minus the other side. 15. I can squeeze it in there. Yep. So now we just have to jam that in our calculator. Okay. So the square root of 22, then parentheses, 22 minus 17, 22 minus 12, 22 minus 15. We get 87.75 is the area for that thing. Hey, that's what I got. That's awesome. Good news. Okay, there'll be a worksheet with areas, just some different figures I want you to find the areas for. That one will be graded for correctness. But the stamp itself is effort-based. You need to be able to do these and be good at them. Bring your questions to me. Here's our stamp, page 527. This is stamp number 3 in this process. We have the power reducers and double angle formulas. We have the law of sines. And then now we have the law of cosine. All right, guys, moving on. Keep fighting through this stuff. Peace.